Hello, fifth graders. I'd like you to set a goal for yourself soon, before sixth grade. Be able to take any two fractions and add, subtract, multiply, or divide them. This is one of the big topics of fifth and sixth grade math. I'll be honest with you. We will cover it again. We will review it in sixth grade. I like to be honest with my students. But on the other hand, please don't wait. If you can master this now, there's no reason not to. Let's take a look at this. And one of the cute little things that I've done through the years, I enjoy doing, is to take the same two fractions and add, subtract, multiply, and divide them. Yeah, just a nice little approach to this. Let's talk about estimation. We'll talk about estimation for each of these operations. This is close to 5. This is close to 3. 5 plus 3 is 8. 8 is a fine estimation for this sum. But sometimes we can refine an estimate. We can be even more specific. You should realize that 2/3 plus 1/5 is less than 1. What do you add to 2/3 to get 1? It would be 1/3, right? 2/3 plus 1/3 is 1. You should also be comfortable with the fact that 1/5 is less than 1/3. So we're actually not going to reach 8 here. 4 plus 3 is 7, and the 2/3 plus the 1/5 is not quite 1. We're going to use 15 as a common denominator, of course. We can always take the product of the two denominators as our common denominator. Sometimes we can use something less, but not here. I want to say another word before we get into solving this, coming up with this sum, and that is the role of improper fractions. You should all know immediately that 4 2/3 is 14/3. The 4 by itself is 12/3 plus 2/3 is 14/3, and the 3 1/5 is 16/5. The 3 all by itself is 15/5, plus 1/5 is 16/5. But we're not going to use improper fractions here. I have an analogy that I use through the years. Let's say you're in Attleboro and you want to travel to Providence. Well, get in your car, your parents' car. Have to wait a few years before you get in your car. Get in your parents' car and travel to Boston. And turn around, head back south, go through Attleboro, and get to Providence. Now that would be a very inefficient way to go to Providence, unless you have a reason to go to Boston. That's kind of like what it would be here to convert to improper fractions. You'd be making fractions that contain big numerators. You'd have to deal with big numbers, and then when you get an eventual answer, an improper fraction, to have an idea of its value and to see if it's reasonable, you'd have to convert back to a mixed number. We are going to have to use improper fractions for multiplication and division, but I urge you, please do not do that with addition and subtraction, because it's like traveling to Boston first and then going to Providence from Attleboro. So 4 2/3. Many of you can do this one mentally already. 4 2/3 is 4 10/15, right? We're going to multiply the numerator and denominator of the 2/3 by 5. Why 5? Well, that's the other denominator. This is how we always add fractions. And we're going to multiply the top and bottom of the 1/5 by the 3, the other denominator. And the 1/5 is, of course, 3/15. So what we have now is 4 10/15. I'm having a problem with markers running out, same as in school. 4 10/15 plus 3 3/15. And I think at this point I need to get a little bit technical in terms of why we don't have to use improper fractions. What we can see here is we've got 4 numbers being added together. The 4 10/15, a mixed number, is always really a sum. We don't write the plus sign there, but it's really there. So we have 4 plus 10/15 plus 3 plus 3/15. And when we're adding a bunch of numbers, we can do it in any order and grouping we want. That is the commutative and associative properties of addition. So uh, generally, students learn to write these vertically. And when you write them vertically, you would add the 4 and the 3, and then you would add the 10/15 and the 3/15, and you'd have your result. But I'd like to suggest this, that when you write them vertically like that, you're really using the associative and commutative properties. You're sort of assuming it's okay, and it is okay to add the two mixed numbers and add the add the two whole numbers, add the two fractions, and then add those results. That is accomplished when you write them vertically, and it's legitimate. It's okay to do. So we get 7 and 13/15. This is a relatively easy one because it did end up being less than it. The result was less than 8. In the future, you might get a situation where you'll have to further simplify the mixed number that you end up with. But here we get 7 and 13/15. This goes along with the estimate that we made earlier, that the answer would be less than 8. So there's the addition. And we are 25% or 1/4 of the way through the calculations with these two mixed numbers. The significant fact about these two mixed numbers, as far as the subtraction is concerned, is that the 2/3 is greater than the 1/5. We've talked about this before. This is an easy subtraction for that reason. If the two fractions had been reversed, if it had been 4 and 1/5 minus 3 and 2/3, that's a more challenging subtraction that we've looked at and we'll look at again. But we'll just keep it simple here. Now, again, the vertical method would work fine here. If we were to set up this problem vertically, we would have 4 and 10/15 minus 3 and 3/15, right? And I'm assuming that we remember from the addition what we remember that the 2/3 is 10/15 and the 1/5 is 3/15. If we set this up vertically, 4 minus 3 is 1, 10/15 minus 3/15 is 7/15. This is the answer, 1 and 7/15. Okay, and see how we would set it up vertically down here. And the fact that the answer came out to be more than 1, 4 minus 3 is 1, of course. The reason the answer is more than 1 is because the 2/3 is greater than the 1/5. And that 1/5 is being subtracted, just like the 3 is. When we write this minus 3 and 1/5, mathematically the way that works out is it's minus 3 and also minus 1/5. So we can set this up horizontally, similar to what we did with the addition. Two of the numbers, though, are negatives. They're being subtracted. They're positive numbers being subtracted or negative numbers being added, which we'll get into in the future. So if we were to see this as adding -3, which it is, and adding -1/5, then we would have, again, the idea of the commutative and associative properties of addition, allowing us to do it in any order. So we can group the two whole numbers together. 4 minus 3 is 1. And then 2/3 minus 1/5 is 10/15 minus 3/15, 7/15. This is just a sort of a technical way of explaining to you that this vertical method here works. Don't if this is confusing to you up here, don't worry about it. I like to sometimes show some of the underlying theory of the math to students. So this is an easy one. The addition was easy. So is this one. You should be able to easily handle mixed number addition and subtractions like these. They can get a little bit more challenging, and we'll get to that later. Now, ladies and gentlemen, if we rely on our estimation skills, like we did with the addition of these two mixed numbers. We would say this is close to 5, this is close to 3. We expect an answer near 15. And I'm actually not sure whether the answer is going to be more or less than 15, but I know it's going to be nowhere near 12. Okay? Remember the classic mistake about multiplying mixed numbers, and don't do it. The answer here is not 12 and 2/15. You cannot simply multiply the 4 times 3 and the 2/3 times 1/5 and put them together. I would urge you at this point, if you think you need to, go back and look at a video I made some weeks ago about 2.5 times 2.5. The fact that that's not 4 1/4, it's actually 6 1/4. Please look that up and refresh your memory. Don't make that mistake, okay? Here we're going to convert each of these fractions to each of these mixed numbers to improper fractions. If we had done the mistake 4 times 3 and 2/3 times 1/5, put them together, we're not multiplying all of this number by all of this number. We're just taking a couple of pieces of it. And my video of 2.5 times 2.5 actually shows that, literally with some geometry, how some pieces to the problem are left out when you make that mistake. We said earlier that this is 14/3 times 16/5. And now the easiest thing that we do in middle school math is to multiply two fractions. Multiply across the top and bottom. And of course the denominator will be 15. And I talked earlier about the numbers getting big when you deal with improper fractions. We now have to do 14 times 16, probably off to the side most of the time. We'll have to do that. And it looks like it's 224. 224. I think that's what 14 times 16 is. Hopefully I did that correctly down here. And this is the answer. There's nothing wrong with it. But the idea of a mixed number is it gives us a better sense of the value of the number. Where is 224/15 on the number line? Might be hard to realize that until we do this. And of course we can divide 224 divided by 15. We can use a division, and instead of giving the answer with a remainder, 15 of course goes into 22 once. We can put a 1 in the tens place. We knew the answer would be more than 10. We're expecting an answer near 15. So a 1 in the tens place there. 1 times 15 is 15. Subtracting gets 7. 22 minus 15 is 7. Bring down the 4. Ask how many times 15 goes into 74. Well, I happen to know 5 times 15 is 75. Ooh, I honestly, until this moment, until I saw that 74, I didn't know whether the answer would be more or less than 15, but 5 times 15 is 75, so the 5 is too big. We've only got 74 here. So we'll put a 4. 4 times 15 is 60. And subtract that remainder will become the numerator of a fraction. See, the idea is 14 times 15 is, what's that going to be? I guess it's 14 less than this. 14 times 15 is 210, but we've got 224/15. So I think this is right. This, what we've got here is 210 over 15 plus 14 over 15. We don't really see the 210 in our division here with the algorithm, but if you want to check that out, 14 times 15 is 210, and that's 14 shy of the 224. So that's why that mixed number is 14 and 14/15. And again, very close to the 15, which was our estimate. 14 and 14/15. All right, let me hold this up here so all the work is visible. You can pause if you need to. And now we're 75% or 3/4 of the way through. We just have to do the division. Let's talk estimation about the division. 4 2/3 divided by 3 1/5. Let's recall the definition of division. Whatever this number is here, we have to be able to multiply it by 3 1/5 to get 4 2/3. Well, it should be obvious to you that that number is between 1 and 2. 1 times 3 1/5 is only 3 1/5. It's less than this, so the 1 is too small. 2 times 3 1/5. We can use the distributive property here. This is an easy multiplication. 2 times 3 and 2 times 1/5 and put them together. We don't have to convert to an improper fraction here, right? 2 times 3 1/5 is 6 2/5, not 6 1/5, 6 2/5. So the 2 is too big, okay? The answer is somewhere between 1 and 2, and we'll ultimately get the answer as a mixed number, 1 and something. For both multiplication and division, we convert to improper fractions. So the 4 2/3 is still 14/3, and the 3 1/5 is still 16/5. To divide by a fraction, multiply by its reciprocal. We covered this, some videos from a couple of weeks ago. I showed you step by step why it works to do that. 14/3 divided by 16/5 is equivalent to 14/3 times 5/16. Keep that first fraction the same. Flip the second one and multiply. To divide by the 16/5, multiply by the 5/16, which is the reciprocal of the 16/5. There's a nice little phrase that is sometimes used. Keep, change, flip. Keep the first fraction the same, change the division to a multiplication, and flip the second one. Now when we multiply across the top and bottom, we get, we'll do these mentally. 14 times 5, that's 50 plus 20, right? Use the distributive property. 70. And 3 times 16 is 30 plus 18. 30 plus 18, 48. Now, at some point, we're going to spend some time talking about canceling that we could have done here. Some of you may be aware that to save time, to make things a little easier, perhaps we could have done a process called cancellation with the 14 and the 16. But really not a big deal here, except we notice over here that these are both even. So before converting to a mixed number, I'm going to divide the top and bottom here by 2, which we could have done back here with that canceling process. But let's just save that for another day. I won't show the divided by 2, but 70 divided by 2, 35. 48 divided by 2 is 24. So this is also the answer. This is the answer. It's not wrong. This is equivalent. So this is also the answer. And just to, again, confirm that it's what we expected, to confirm that it's reasonable, convert this to a mixed number. And you should be able to do that mentally. I'm going to show 24 24ths plus 11 24ths down here. But that's not difficult to do mentally. This is 1 plus the 11 24ths, right? 24 24ths plus 11 24ths is 35 24ths. You break it apart like that to get the 1 and 11 24ths. This is a reasonable answer because, as we said at the beginning of this division, the quotient, the answer, had to be somewhere between 1 and 2. So we can be comfortable with this answer. So we'll do more of these in the future, but we just successfully added, subtracted, multiplied, and divided 2 mixed numbers. Take care, and I'll see you soon.